Okay, hello there. So let's jump to the privilege escalation in this Linux machine. So as you saw in the previous video, we have already gotten a shell with the remote code execution vulnerability in Marcus Junk plugin of Roundtube, and now we really need to escalate our privileges to the peter.turner at hybrid.vl user, because if we manage to compromise this user, we will probably somehow acquire a valid set of credentials for the domain in order to finally be able to enumerate it. So right here you can upload link piece and do some enumeration. You can search for passwords. Okay, I actually spent several hours in this part, but what is interesting here, and you should check, is the settings in the network file share. Okay, so right here we can see the see the contents of this directory, and we want to experiment a bit with it regarding writing file permissions. Okay, we saw that we could or even download files, but what happens if we want to write a file in that share? So let's log in as an ordinary user, and let's say that I want to create a test file in this network file share. Okay, so let's see if it is here, and it is here. But what is interesting here is this. If we go here and list the contents of the network file share, we can see that the test.txt is owned by Priest. Okay, it's my attack user. Now if we go here, we can see that we don't see the name Priest anymore, but we see this user ID. Okay, so this happens because Priest, while he's a local user in my attack machine with this UID, he's not a local user in the compromised machine. But we can see here, and this is the heart of the vulnerability we're going to exploit for our privilege escalation, that the UID remains the same. So what we could now do is probably try to hijack that UID. So we can do this. We can try and find the UID of that user of interest here in the compromised machine, and we can try to create that user with that very specific user ID in our attack machine and start placing files in this share, because they are going to inherit the UID and the username that created them from the attack machine. And because the user exists in the compromised machine as well, here we will see a file, for example a test.txt file, that will be created by this very same user. So let's go ahead and try to do just this. Let's delete this test.txt file. Okay, and let's go here and let's try to add I'm sorry, let's skip back to my root shell, and let's try to add a user with that specific UID. Okay, now if we go to our etc password file, we can see that we now have this Peter Turner with that specific UID. Okay, now this UID is unusually high for Linux machines. If you have problems creating a user with that high UID, then you can modify the etc login .devs. Okay, you can modify the max UID option here and set it to a higher number. Okay, like I did here. So if you have a problem, just try to modify the specific setting in this file. And now that I've created, let's go and run as peter.turner. Okay, so let's say that I want to create again a file in the mounted directory. Okay, and now let's try list that directory. We can see we have Peter Turner at hybrid, and we also have this. So since the user with that user ID exists in both machines, we will also see the correct ownership in the compromised machine. So we know that we can hijack this user ID here and consequently that user. So what we want to do now is try to hijack a useful binary that will grant us code execution as Peter Turner. And that binary, of course, all right, let's delete the test.txt, we don't need it anymore. And that binary is the bin bash. Okay, so let's copy the local bash binary of the compromised machine right here. Okay, and we can see that it's owned by the 3w-data because this is the user we are currently at the compromised machine. This is the user that we have a shell in the compromised machine. And if I go here, okay, if I go here and check this, I can I'm sorry, if we go here and check this, we can see that because the 3w-data user exists in our machine as well, we'll see the same thing. So what I can do now is copy the mntVL bash right here. Okay, I'm not allowed to do it. Okay, now let's try to do something. Oh yeah, I'm sorry, I should exit this low privilege user, and let's try now to copy that bash binary right here. Okay, so we've copied it here, and since we copied it as the root user, we now have root ownership here. So let's go and log in again as Peter. Okay, I'm sorry. Yeah, I'm sorry. I kind of fucked up. Yes. So wrong command. Let's try and go here and let's try to copy the mntVL bash here. Okay, we can see that we have copied it. Previously we could not because this directory that I've used for this chain is owned by root, so I could not actually copy stuff in there. Okay, now the interesting thing is that now that I've copied it here, we have Peter Turner ownership. Okay, as you can see, the ownership has changed because I've copied it as the Peter.Turner. So right now, if I go here and delete bash and copy this binary to the mnt vl directory, it might take a while. It's 1.4 megabytes and the connection sometimes is not that good. But it will eventually. I think we can already see it here. We can see that now that we have copied this binary back to the network file share, it has inherited the Peter.Turner at hybrid.vl ownership. And we can now try to set the SID, change mode plus S at mnt vl bash. And now we're going to see, we will list once more everything right here. We can see that we have managed to set the SUID here. So right now I can clear my screen and place the full path of this newly created and hijacked, essentially it's a hijacked bash binary. And now if I say ID, I can see that I've inherited the EUID of Peter.Turner. So if I go to home now, I can go here and I'm able to list all the directories and the files in here. Okay, so what we have essentially done was hijack the bash binary and exploiting the fact that when we write files in the network file share, the UID is inherited. So if we create the exact same user right here, we can hijack the bash binary. So let's, now you can see we have the flag file here, but this is extremely interesting. Okay, this is a key pass file. So let's try to copy that to the TMP directory. Okay, let's exit, go to TMP, and we want to transfer that file to our machine. Now, of course, if we go to we go back to the shell with the EUID as Peter.Turner, we can try to add our public SSH key to Peter's SSH directory and try to log in via an SSH connection. But right now we really want to focus here, because here you will definitely have some juicy details. Okay, it will definitely have some nice passwords. Okay, if of course we are able to crack it or open it. So the way I'm going to use to transfer it is launch Python server. Now if you are not running as root, you have to use a high port, so let's try and use this. Okay, it's already in use. Yeah, probably it's running because I launched a server previously. And let's try to get this file. It's not found. Yes. The server is running, but it's running on a different directory. So let's kill it and let's run it from here. And what the fuck is going on now? Yeah, I'm sorry, I should have used the port here, and we have the passwords.kdbx. Okay, it's a key password database. We can try to crack it with John, but before we try to crack it, let's try to open it. Okay, you can see that a master password is required here, and as I mentioned before, we can try and crack it, but if you remember, we already have some interesting files here. Okay, for example, we have this Dovecode users, and we have this username and password. Now, if I try to log out and try these credentials here, we can see that we are successful in logging into Peter's mailbox. Okay, and we can see this email that was sent by the administrator. Of course, here I don't think, no, let's see, could we change the username? Yeah, we could change our identity here as well, so we could use this account as well to hijack the I'm sorry, to exploit the Marcus Junk plugin. Of course, don't make the mistake of assuming that we would land the cell as Peter.Turner, because the RunCube application runs as 3W data. Okay, so it doesn't matter which user you're going to try to exploit, we are going to get a shell as 3W data. Okay, now what we should always keep in mind, and it's always a good idea to try, is password reuse. As you remember, we already tried in the first video to test this password if it's a valid domain password. Of course, it failed, but we should also consider, instead of trying to crack the password, to crack this keypass file, we should see if Peter did the mistake of reusing his email password. And interestingly enough, he has done that severe mistake. So right now we can see that we have two set of credentials. The first one is the mail, which is obviously Theta East Toll, and the other one is used for the domain authentication. So if we copy this password, we can see that we have found Peter's password. So right now, if I go and try to log in via SSH as Peter Turner, let me find the IP address again. Yeah, I'm sorry, I need to put this, yeah, I'm sorry, I'm a bit tired and I don't know what I'm doing sometimes. Okay, let's place this password. It didn't work because we didn't copy that password, obviously. Okay, so here we can see that this password worked, and we know it's a valid domain credential already because we managed to SSH here. And remember, this is not a local account, it's a domain account. Okay, so if we say crackmap exec, and we use the live host file here. We can confirm that it's a valid set of credentials. Okay, if it wasn't a valid set of credentials, we would not be able to SSH to the machine as well. Okay, now another interesting thing that we should check here, since we know the password, is try and do sudo -l. Let's paste the password again, and we can see that Peter can run everything on Mail01. So Peter is actually a root user here. Okay, so if we say sudo su, I'm sorry, I'm sorry, wrong command, I wanted that to type clear. So we are root here, we can go to the root directory and read the flag. This is the second flag, so there's a flag in home Peter Turner here, and there's a second flag in the root directory of Mail. Okay, so we've fully compromised the Linux machine, we have a valid set of credentials, and now in the next video we are going to see how we can reach domain compromisation. It has several very interesting steps that you will not easily find in other labs out there. So the next video is just as much juicy, maybe even juicier than what you watched already. So thanks for watching, and I'll see you in the next video.